In this second objective, we're going to take a look at the production function and hiring workers in this case, and then what happens to our output. Goes back to a couple principles, and the first one is the cost and benefit. As we add additional workers, how do they benefit us? We're also going to look at the law of diminishing returns. The law of diminishing returns is as you add input, the output, marginal output, will tend to decrease. And so we're going to take a look at that and ask some questions about it. So let's go ahead and get after it. Thank you. Let me share my screen with you. I always say the fourth take is a charm. Okay. So again, the costs of production. All right. What is the production function? The production function basically says, as we change inputs, what happens to output? So it's a relationship. And we can look at it in a table, an equation, or a graph. And we're going to go ahead and present the production function using an example. So in our example, we have Farmer Jack, and he's going to grow wheat. He's got 5 acres of land, and he can hire as many workers as he wants to hire. Later on, we're going to classify these costs according to their categories, land being a fixed cost, and we'll define that later on, and workers being a variable cost, again, which we will define in the next objective. So let's go ahead and look at this in a table form, and then we'll look at it graphically as well. So at this point, we're going to say that Farmer Jack does none of the farming himself. He's a coordinator. Or let's say he's retired and he is hiring people to solely produce this wheat. If he has no workers, he doesn't get any output of wheat. Now he decides to hire 1 worker. His output of wheat increases by 1,000. Okay, so we're just saying, okay, we went from no workers to 1 worker. That's a gain of 1. And how much wheat do we now have? 1,000. So you can look at this as the cost being the worker. There's our cost. An increase in cost of 1, our benefit, an increase in 1,000 bushels of wheat. Now, what happens when I add a second worker? I want you to think about that for a moment. Let's say worker 2 is exactly like worker 1. They are carbon copies of each other, have the same motivational levels, the same everything. How many bushels of wheat do you think that the second worker will add? And I can tell you, because I know the law of diminishing returns, that worker 2 is going to add something less than 1,000 bushels of wheat. How do I know that? Well, think about this. If there's only 1 worker, they can decide when to do something, when not to do it. They have all the capital available to them at their disposal when they need it. Yet when Farmer Jack hires the second worker, there's a thing which has to take place, and this thing is called a coordination of effort. If you've ever sat in a meeting, you know that you're coordinating effort. And while you're coordinating that effort, although important to the work itself, work is not actually being done. Meaning here, we are not putting out additional wheat. So I can tell you that when we hire this second worker, because of coordination of effort, then what's going to happen is we're going to have something. Let me go ahead and. We're going to have something less than 1,000. So let's go ahead and look. Notice when we hired the second worker, it is, in fact, a gain of less than 1,000. We hired the first worker, we got a gain of 1,000. We hired the second worker, we now get a gain of 800. Notice as we continue to hire workers, the gain that we get from each worker is less and less. So if we were to look at this and say the gain of the next worker is 600, the gain of the next worker is 400. Notice I'm looking at this per worker or incrementally as we've defined it in our course, and 200. If we look at this graph right here, as you can see with the graph, that for each worker, this idea of the quantity of output is increasing, but it's increasing at a decreasing rate. So if I were to take the slope and calculate it here, it would be very positive. Here, a little less so. Here, a little less so. Again, remember chapter 3 when we talked about this idea, a little less so, barely positive. And what do you think might happen here at worker 6? Worker 6 might be here or here, but it's actually going to start to decrease. So what happens is I ask myself, should I hire worker 6? And the answer is no, because worker 6 is not going to produce any more output, probably be 0 here at worker 6. So what I do is I take a look at, okay, if I hired worker 6, they're not giving me any benefit. So as I look at that cost benefit decision, worker 6 does not increase my output. So I would hire the right amount of workers to hire right here is 5 workers. I will have an output of 3,000 bushels. That 5th worker will still be beneficial. Again, we're ignoring the cost of the labor at this point. But I can tell you that the law of diminishing returns means that as you add this input, your output will increase, but it will increase at a decreasing rate. Okay, what we've actually just done is we've calculated the marginal product of labor by looking at it incrementally. And again, we're just looking at how adding workers while holding labor, while holding land constant, how do those workers increase our output? Okay, now we're going to start with some notations because we're going to look at this a little more mathematically, but you can kind of see we're just looking at things incremental. So what we're going to do to measure the marginal product of labor is we're going to say the marginal product of labor, or MPL, marginal product of labor, is equal to the change in quantity divided by the change in labor. So this becomes another formula for us to know and to have. And again, it helps us make some of those decisions that we talked about in Objective 1. Okay, so here's an example. This is just the graph that we had a moment ago, and we're going to do the same thing, knowing that the marginal product of labor is equal to the change in the quantity divided by the change in labor. In this particular scenario, we're going to say our change in labor is 1. So 1 minus 0 is 1. 2 minus 1 is 1. 3 minus 2 is 1. So we're looking at these as a factor of 1. Then we want to calculate our change in quantity. So change in quantity just says we went from 1,000 minus 0, that is a benefit of 1,000. We went from 1,000 to 1,800, change 800. 2,400 minus 1,800, change is 600. 400 and 200. Okay, now you're probably seeing the pattern that the marginal product of labor, as the labor goes up by 1 unit, the marginal product of labor decreases by 200. This is textbook land. It doesn't always work this nicely. So what we can do is simply divide 1,000 by 1. Our marginal product of labor is 1,000. 800 by 1, 800. 600, 400, and 200. Okay, let me erase my ink on the slide so you can clearly see how this works out. Sometimes this doesn't want to grasp my, there we are. Okay, there we go. So there's our marginal product of labor. Now, we can look at the marginal product of labor is the slope of the production function. So our production function, the slope of it is the marginal product of labor. Remember some time ago when we started introducing marginal, we said that marginal is a slope of whatever we're looking at. So here, the slope of the product of labor. So the marginal is the slope of the product of labor. And here is the product of labor. And the marginal product of labor is just the slope of the production function. So this graph beside of us here on the right-hand side is just the production function, which illustrates as we add workers, as we go from 1 to 2, 2 to 3, we can say, okay, the number of workers, 1, and our output is 1,000, so we graph that. Then to determine our marginal product of labor, we're going to take that change in the quantity divided by the change in the labor, or the slope of the production function, and that's going to give us our marginal product of labor. Here's another example just to make sure you understand it. If you do, go ahead and fast forward. Here we have a small production firm that makes sweaters. Here again, these are our number of workers. Here's our total output. So as we look at this, we can say we added 1 worker, right? That's our change in labor. So I'll put change in labor. We added another worker. Okay, incrementally going up by 1. That's not always the case, but we're going to work that here. Okay, when we added what is our change in output, change in quantity. Here we went from no workers, no output, to our first worker gives us 4 output. So our output here will be 4. 10 minus 4 is 6. 13 minus 10 is 3. 15 minus 13 is 2. And 1. So our marginal product of labor, again, which is the slope of the production function, is 4, 6, 3, 2, 1. So here's my question to you is how many workers to hire? Now, most of you would say, okay, I'll take the 5th worker because I am still getting some output. And again, we are kind of ignoring some questions that we would really need to answer this well, and that is, what's the cost of labor? What are we paying our workers per hour? Because if the cost of labor here is, say, $10, okay, and we can only sell a sweater for the price of sweaters is 6, I would say, well, we're definitely not going to employ 5 workers, and so on. So we'll look at that coming up. Okay. Here is our sweater example. So here's our output of sweaters graphically. And here's our quantity of labor. Notice it obeys the law of diminishing returns, that this production function increases at a decreasing rate. Remember that the marginal product labor is just the slope of this production function. Okay. Now, if we took this production function, and we were able to lift it off the screen and flip it over, we would end up with a total cost curve. Because right now we're only saying our only cost to this is labor. So notice that this production function, here it is convex, here it is concave, and notice that as we look at our total cost, and again, that would be our cost of labor, and our output over here, they're kind of mirror images of each other. Remember, our total cost curve is related to our supply curve. So that's why we look at this. And again, just keep in mind that the marginal product of labor is equal to the change in the quantity divided by the change in labor, or is simply the slope of this production function. Somebody is knocking at my door. I guess they're going to have to wait. So why is marginal product of labor important? Well, it's because we really want to make some good decisions here. Okay? So are we going to benefit from hiring an additional worker? Again, what is the right amount of worker to hire? So why did I know that the output rises by a smaller amount for each additional worker? And this is because that we're holding all other inputs constant. Here, land, we're holding constant. And let's imagine maybe Jack only has one tractor. And if you only have one tractor, you really have to do a lot of coordination of effort. I'm not saying meetings aren't important, but I'm saying that if I'm in a meeting, I can't be teaching at the same time. So that decreases my overall productivity. So the marginal product of labor diminishes as labor rises. And this is true of fixed inputs, things like land, because aren't we eventually going to hit capacity of our land? Aren't we going to hit our capacity of capital? So when I look at this, and I laugh because this is so true in my business, is I like to use one specific pitchfork. Okay, it looks kind of like that when I clean stalls. And if my husband's using it, I am less productive. And so one would think I could just go out and buy another pitchfork, but that's a cost, right? But I have yet to find the exact one that I like. So again, the diminishing marginal product is based upon the law of diminishing returns. And welcome to the third objective for Chapter 13. In this objective, we're going to define all kinds of costs and show you what they mean and how to calculate them. We're going to continue on our example with Farmer Jack and his wheat, but this time we're going to add some cost factors to it, which are really important in determining business types of decisions. So let's go ahead and do this. Okay. So again, we're going to take a look at some specific types of costs. Before I get into the other types of costs, I want to take just a moment and explain what we mean by the cost structure so far. So we're going to look at costs in the short term, okay? Because you'll find out this changes a bit in the long term. And in business, by short term, what we mean is less than or equal to 1 year. So let's start with fixed costs. Fixed costs are those costs that remain constant regardless of the number you produce. If I were to graph them and say that this again is kind of the cost over here, and here's our quantity of output. Fixed cost in the short term will look like this. They will be a flat line, and it doesn't matter if you're producing nothing or you're producing 1,000 units. The costs are the same in the short term. So think of a fixed cost for a business, and here we've looked at GM, so one cost there would be land. That's a fixed cost. It would also be land for Farmer Jack. Another fixed cost might be our building. It might be rent. Okay, so those are some examples of fixed cost. I always ask students, what's a fixed cost to Lake Michigan College for presenting this course? And one fixed cost for them would be maybe the desks or the tables, okay? They are capital, okay, but they remain constant regardless of the number that we produce. I am a fixed cost to Lake Michigan College. My salary is a fixed cost because I get paid the same regardless if there is 10 students or 20. Now, the other type of costs that we want to look at are called variable costs. And variable costs will increase proportionately with output. So this, if I were to draw them, I'm going to go ahead and put cost over here on the y-axis. And here's our quantity on the x. Variable costs increase as output increases. So here we have a 0, here we have 1,000. Notice if we're not producing anything, we don't have any variable costs. So in looking at the Farmer Jack example, workers, especially hourly workers, tend to be a variable cost. Another type of variable cost might be inputs, because as you produce more and more product, you need more and more inputs. So it could be things like tractors or capital in that respect. I ask students also, what do you think a variable cost for producing this course is? And it might be copying or subscriptions like to Zoom. Copying costs would be a cost to Lake Michigan College. Some other types of costs that students like to talk about are electricity. And this is where we have you take cost accounting, because yes, electricity can be a fixed cost, but as you run your machines more and more, portions of electricity are a variable cost. So there are costs which become both fixed and variable. And then we take a look in cost accounting to decide how we want to cost those particular facets that have both a fixed and variable component. So cost accounting. Only non-A I got in graduate school, not that I'm still bitter, but I am. So fixed costs, we're going to call fixed costs, okay? FC will be how we will denote that. Variable costs will be VC. And we're just going to hold these others off to the side as constants because, again, this is an introduction class. So let's go ahead and take a look at Farmer Jack's costs. Farmer Jack must pay $1,000 per month for land regardless of how much wheat he grows. Would that be a fixed cost or a variable cost? If you said fixed cost, you're right. Because, how do I know? Because it's regardless of how much wheat he grows. So that's kind of my prompt to it. Plus it's land. Land is normally a fixed cost. The market wage for a farm worker is $2,000 per month. Is that a fixed cost or a variable cost? If you said variable cost, you're right. Because he decides how many workers he wants to hire. Okay, so here we have the cost of land, which is a fixed cost. We have the cost of labor, which is a variable cost. And then we have this new term called total cost. Total cost is just going to be our fixed cost plus our variable cost, and that will equal total cost, which we're going to call TC. So here, notice because he's charged $1,000 per month, regardless of what he produces, that fixed cost will be $1,000 at 0. So if you want to figure out, or they don't explicitly tell you what a fixed cost is, always look at where the quantity equals 0, and that's going to tell you what the fixed cost is. Here, the variable cost is nothing, so the total cost is $1,000. Okay, and this total cost, because the quantity is 0, is our fixed cost. Okay, let's just go ahead and erase that. I think I want to keep a couple things. I want to keep that land as a fixed cost and labor is a variable cost, add them together, and we get total cost. Okay, so using the information from the previous slide, we're going to say that as the workers go up, now we know specifically how much. We add one worker, and how much does that cost us? That's our variable cost, so that's $2,000. Okay, and then here is our quantity in relationship to what's their production, which we've looked at previously. So there's our fixed cost, there's our variable cost, and here's our total cost. So from this slide, just remember that fixed cost plus variable cost equals total cost. That's where these particular costs have come from. We can then take his total cost and we can graph it. So using just the total cost column from the previous slide, again, remember, total cost is just fixed cost plus variable cost. We then see that the total cost curve is positively sloped. What's interesting, remember some time ago we talked about this, and we said that where the supply curve intersects the y-axis, and this is the y-axis here, right? Where it intersects the y-axis, if we were to follow that over like this, make a nice kind of straight line there, that would be the fixed costs, which means that all of this, let me go to a highlighter here, that all of this section, all of this yellow here, must then be our, you got it, oops, see if I can get it, there we go, must be our variable cost. So we look at the fixed cost, and the variable cost, add those together, and that's where this curve comes from as the total cost curve. And the total cost curve for Farmer Jack is going to be similar to his supply curve. It's related. Supply curve. Okay, now because we're looking at things incrementally, we really want to understand how do costs change as we increase output. So we're going to say that marginal cost, here's that word marginal again, and you know that marginal just means the slope of something, and here we're saying marginal cost. So this must be the slope of the total cost curve. So our formula is going to be the change in total cost divided by the change in quantity. Okay, so let's go ahead and look at an example. Here we have our quantity, that is our output. Here's our total cost, remembering that total cost is just fixed cost plus variable cost. So now we want to look at how do our cost change as our quantity changes. So remember, the marginal cost is going to be equal to the change in total cost divided by the change in quantity. So we're going to look at this incrementally. So again, if we look at this, we can say, okay, we went from 1,000, went from 0 to 1,000. So our change in quantity is 1,000. That's our output, right? We went from a cost of 1,000 to 3,000. So 3,000 minus 1,000 is where we get this 2,000. Then we divide the 2,000 by the 1,000. And we're saying that our marginal cost here is $2 for that first 1,000 bushels of wheat. We can then do it for each additional output and each additional total cost. Okay, so let's look at this total cost curve for a moment. It starts off pretty low at $2, increases to $2.50, $3.33, and then it increases quite a bit. Notice the big jump between 5 and 10. And we're going to talk about that a little bit later on. We can then take this marginal cost idea. Again, let's just make sure we understand what these things are. This is fixed cost plus variable cost. Marginal cost is the change in total cost divided by the change in quantity. And now we can denote a marginal cost curve. So here is a marginal cost curve. To me, it kind of looks like a Nike swoosh. Excuse me. And it's interesting that the marginal cost curve kind of, as we saw in the example, not a lot of increase here from 1,000 to 2,000 or here, but it does increase greatly in this vicinity here. So why is this important? Because we want to maximize our profit. And to maximize our profit, we need to know, should we produce more or less wheat? We want to produce at the highest profitability. Okay, at this point, what I'd like to do is to take a moment and show you where we're going. So I'm going to kind of talk with you a little bit about what these things look like on both the marginal cost and marginal revenue side. Okay, so let's take a look at an example. And this is the example I usually use in class and kind of talk through it. Okay. Okay, this is going to be our total revenue curve. And remember, total revenue is just price times quantity. And we're going to present those in upcoming chapters in terms of they look a little bit different. Here is our total cost curve. And remember, total cost is just fixed cost plus variable cost. If I were to take this curve and kind of slice away some pieces of it and just take a look at, let's see if I can find this section in here. Okay, I'm just kind of going to look at this section in here. Now, what I want to do is to, let's do it that way. I'm going to take that section, pull it off, and then kind of put it over here on this graph. So now what I'm saying here is this is my total revenue curve. Okay. Now, I'm going to go ahead and draw the total cost curve. Okay. And let's think about what that particular curve means. That curve means that we want our total revenues to be as high as they possibly can be. That kind of makes sense to us. And we want our total costs to be as low as they can be. So let's look at this for just a moment. If we take the marginal cost, notice if I look at this section right here And remember, marginal cost is just the slope of the total cost curve. So here, if I were to calculate the marginal cost here, it would be very negative. If I were to calculate the marginal cost here, it likewise would be negative, but a little less so. And again, this would be negative. These negatives kind of state to us that total costs are falling. Now, ask yourself, what would be the slope right here? Well, if we drew a tangent line, you can easily see that the slope right here of the total cost curve, which we would call marginal cost, that marginal cost is equal to 0 here. Because remember, marginal cost is just the slope of the total cost curve. If I were to take this next section, maybe from here to here, and to look at that, I'd say, well, the change in total cost divided by the change in quantity, and that would be positive, right? But not really positive. Then I would take a look here. This too is positive, and a little more so, and then a little more so. So obviously, because the goal is to produce things at their lowest cost, we would want to produce right here at A. Okay? So marginal cost allows us to determine whether total costs are increasing or decreasing. All right. Now, let me go ahead and clean up this graph a little bit. Let's see if I can do this. You'll either erase all of it or some of it. Let's see. Okay. Eraser. Okay, so I'm going to go ahead and erase what I just did with total cost, because now what I want to do is to focus on, I may have to just redraw it, which is fine. Now I want to focus more specifically on total revenue. Now, we said that we want total revenue to be as high as it can possibly be. So I'm going to go ahead and redraw my graph. And I will go ahead and put total revenue in green again. And I'll go ahead and put total cost in red again. Okay, so let's look at total revenue now specifically. So if I'm looking at total revenue, and we're going to learn that there is a thing called marginal revenue, which is just the slope of the total revenue curve, or the change in total revenue divided by the change in quantity. If I look at the total revenue curve and I measure the slope from here to here, okay, we can see that that slope is going to be positive and very positive. If I measure from this point to this one, we could say that too is positive, but a little less so. And here, likewise, is positive, but a little less so. If I look right here at the maximum point, and I drew a tangent line, we could see at that point, total revenue is equal to 0. I'm sorry, marginal revenue. Marginal revenue is equal to 0. The slope there is 0. We could likewise tell, if I measured from here to here, that that is negative and a little less negative, and then more negative, and then even more negative. So this marginal revenue allows us to tell how total revenue is changing. Now, the 2 points I want you to kind of calculate, or to kind of focus in on here, I'm just going to redraw that. The 2 points I want you to focus here is the idea that I want total revenue to be as high as it can be, and I want total cost to be as low as they can be. Okay, so I want to know at what point are these farthest away from each other. So again, we said this is the point at which total revenue, marginal revenue equals 0. It's also the maxi-max point for the total revenue curve. And so that's where it's highest. This point right here on the total cost curve is where marginal revenue is equal to 0. That's wrong. Marginal cost is equal to 0. Let me erase that for just a minute. There we go. Okay. Marginal cost is equal to 0. So this is where total cost is as low as it can possibly be. So where these two curves are farthest apart, right here, is where, and this is the important part, profit is maximized. And that's something we really like in business. Now, how can I use all this to know what more or less wheat? Well, I could follow this down and I could say at this quantity right here is my sweet spot. That is where profit is maximum. And profit is maximized where marginal revenue is equal to marginal cost. So this is a wicked important idea that marginal revenue and marginal cost, where those two meet, that's where profit will be maximized. I wanted to show you kind of what we're doing here and what we're thinking so that you can say, okay, well, if, for example, as we learn this, I wanted to see where we're trying to get to. If we're, for instance, producing at a quantity that is less than where marginal revenue and marginal cost meet, let's see if I can find my, there it is. Okay. And we're producing at a point here, well, notice that marginal revenue is greater than marginal cost. And yes, we're profitable, but we're not as profitable as we can be. So marginal revenue here would be greater than marginal cost. Therefore, total revenue is greater than total cost. So we are operating in a profit, but we're not as profitable as we could be. So in this case, what we would want to do is to increase our quantity. If, for instance, we were beyond that sweet spot, say right here, notice we are still profitable. Okay? And notice that this is still happening. However, what we would want to do if we're past where profit is maximized, yes, marginal revenue is still greater than marginal cost. And yes, total revenue is still greater than total cost. But here, to increase our profitability, we would want to decrease our quantity. So I think this just gives us a good kind of roadmap to where we're going with all of this. Again, sometimes it's a little frustrating because we don't talk about all of these things at the same time for ease of learning, but I just wanted to show you where we're going. So again, the idea here is to think at the margin or to think at the slope, and that margin idea is how things are changing, how we view incremental change in both total revenue and total costs. Okay, great. Okay, that's the end of this objective, and I think I've given you lots to think about. And just to kind of recap, so at this point, what you should know, okay? Okay, so let's take a look at everything we've learned so far. So we know that profit is equal to total revenues minus total cost. Total revenues being price times quantity. Total cost being fixed cost plus variable cost. And remember, for an economist, we would add in opportunity cost. We want to look at things marginally. So we've learned so far that marginal revenue is equal to total revenue, the change in total revenue divided by the change in quantity. We also are going to look at the idea of averaging this stuff. So in terms of costs, we're going to say that an average total cost or ATC is equal to total cost divided by quantity. For average marginal costs, no, that's wrong, sorry. For average fixed cost, which we will call AFC, that is equal to fixed costs over our quantity. We also have average, you guessed it, variable, which is AVC, and that is variable cost divided by quantity. These we're going to look at in an upcoming objective. At this point here, you should know that total cost is equal to fixed cost plus variable cost, and marginal cost is the slope of the total cost curve, and that marginal revenue is the change in total revenue divided by the change in quantity. Good.